Welcome to the next lecture on descriptive statistics with R software. You may recall that in the earlier lectures we had discussed that how R is going to be used for different types of computation when we are trying to use the scalars as well as data vectors. In this lecture we will continue with the same topic, and I would try to show you that in R there are two types of computation. One using simple operation where you have to define, and beside those there are some built-in functions, and those built-in functions can be used directly over the data or the data vector to obtain the required outcome. In this lecture I will also show you that how you are going to handle the R software when some values or one value in our data vector is missing, which is not available due to any reason. So let us start our lecture here. Now what I will do, I will try to take some examples, and through those examples I will try to show you and illustrate that how to use the built-in function. There are many functions available, so it is not practically possible for me to cover all the built-in function, but I will take sufficient number of examples so that you are comfortable in using all other functions. So let me take here the first example, that suppose I want to find out the maximum among some values. For example, I am taking here a data vector which contains 4 values: 4.2, 3.7, minus 2.3 and 4, and I really want to know out of these 4 values whichever is the maximum out of them. So you can see here, means obviously because there are only 4 values, so you can see here that this 4.2 is the maximum value, and once you enter it here it will give you this value 4.2. And if you try to do it over the R console, here is the screenshot. Well, I will also be showing you later on that how to do this thing. And one thing what you have to observe here, that earlier I had told you that whenever you are trying to give data, you have to give it in the form of a data vector using the C command. But there are some built-in functions which can be used without using the C command. So I am giving you here an example of this max function. Here you can see here in this case and in the second case I am finding the maximum among the same set of values, but here I have used here the C command. So here I am trying to combine the data using the C command for these 4 values 4.2, 3.7, minus 2.3 and 4, and here also I get the same outcome. And here is the screenshot of this thing. But here I would like to give you one advice. Well, it is more difficult to keep a track that which built-in function is going to use with the C command and what are the built-in function which are used without the C command. So I will say the simple rule of thumb is this: always use the C command. So whenever I have to give a data vector, without creating any confusion, without creating any problem, I will simply try to give the data vector using the C command. Right. Okay. Similarly, in case if you want to find out the minimum. So minimum, again I am trying to take the same value, but here in this case the command here is MIN, and what was the command in the case of maximum? It was MAX. Right. So now in case if I try to write down here MIN, and inside the bracket if I try to give here all the data values, and if I try to press here enter on the R console, then I get here the value minus 2.3, and you can see yourself here that out of 4.2, 3.7, minus 2.3 and 4, this minus 2.3 is the minimum value. Okay. So minimum and maximum are the functions where you need not to write the entire program yourself, but somebody has already done the programming to find out the minimum and maximum value, and that program has been renamed as say MIN and say MAX, and you simply need to use it. But definitely, as I told you, that R is not a black box. So in case if you really want to know that what logic has been used, what programming has been used, it is possible to look into the steps which are used in finding these values. Okay. Here is of the same operation, and again I am trying to show you here that here I am not using the C command, and here I am using C command. Means the data is combined using the C command, whereas in the first case the data is not combined using the C command, but in both the cases the outcome is the same. So again I will advise you that always use the C command to combine the data vector. And here is the output or the screenshot. Now I will try to show you that how these things are happening on the R console, right. So let me go to here this thing. First I try to copy this command and I come to here R console and I try to paste this here. So you can see here this will give you 4.2, and yeah, in case if I want to write down here the C command, you can see here. Yeah, so now the same data vector has been combined using the C command, and if you see the answer is going to be the same. And similarly, in case if you try to take here another example here, suppose here between 60, 20, say 56, 87, 97, 35 and so on. So you can see here the maximum value here is 97, right. Okay. Now similarly, in case if you try to find out the minimum, then I can do here, I can use here the command MIN over the same data set 4.2, 3.7, 2.3 and 4, and you can see here now the minimum value is coming out to be minus 2.3. And similarly, in case if I try to use here the C command here, even then you will get the same outcome, right. And similarly, if you try to take here another value here, and if I try to say here minimum of the data vector between 56, 23, 98, 65, 74, 34 and so on. So it comes out to be 23. So you see here I am trying to take a very small data set where you can verify yourself that whether it is giving you a minimum value or a maximum value. But these built-in functions are very useful when you are trying to deal with a huge data set where there may be 5,000 values, 10,000 values or 20,000 values or so on. There you cannot find out these values manually. So these functions help you there. Now if you try to understand, I have taken here two examples, MIN minimum and MAX maximum, and I have illustrated how you can operate it over a data vector. Now similar to minimum and maximum, there are some other built-in functions which are available in R. There is a long list, but here in this slide I am trying to give you an overview of those built-in functions and how to use those built-in functions. The process and the procedure is exactly the same what you have learnt in the case of minimum and maximum. For example, in case if you are interested in finding out an absolute value, right, then you simply have to write here ABS inside the brackets. You simply have to give here the data vector. Even a single value or a vector value, both are acceptable. Similarly, in case if you want to find out the square root of any value or any data vector, the function is sqrt. And similarly, in case if you want to find out the rounding of value, the function is round. If you want to floor, the function is floor. If you want to ceiling, then the function is ceiling. If you want to find out the sum of two numbers or say sum of two vectors, then the function here is sum, and for product the function is prod. And similarly, if you want to make different types of logs, these functions are there, for exponential functions are there, for trigonometric functions sine, cos, tan, etc. are there, and hyperbolic functions sin h, cos h, tan h, etc. are also there, and there is a long list. But now I will try to take here some example, and I will try to show you how you are going to use them. For example, in case if you want to find out the square root of any value, suppose I want to find out the square root of 4, right. So, in this case I simply have to write it SQRT and inside here single value 4. And if you try to see it here, this value will come out to be 2. Now, I will try to illustrate you that if you want to find out the square root of a data vector, then exactly on the same way as addition, subtraction, multiplication, division, they are operated over each and every element in the data vector. Similarly, this square root operator will also be executed over all the elements of the data vector. For example, in case if I try to take here a data vector here C, say 4, 9, say 16 and 25. And suppose if I try to find out the square root of this data vector, then this will be operated like this. Say here C square root of 4, square root of 9, square root of 16, square root of 25. And this answer will come out to be here 2, 3, 4 and here 5. So, you can see here in this case I am trying to do the same thing, and the outcome is coming out to be here 2, 3, 4 and 5. And here is the screenshot of the same operation, right. Okay. Now, and similarly means if you try to take here another example that you can try yourself, try to find out square root of 9 and then square root of this another data vector containing the values 9, 25, 36, 49. So, I am just leaving it for your practice. Okay. Now, another important aspect, sum and product. There is a built-in function here SUM, and this functions find out the sum of all the values inside the data vector. For example, in case if I want to find out the values of 2 plus 3 plus 4 plus 5, then I can give these values in the form of a data vector consisting of 4 values 2, 3, 4, 5, and then I simply have to operate it here and write SUM of this data vector, and this will give us the value of 2 plus 3 plus 4 plus 5, that is the summation of all the values inside the data vector, and this value will come out to be here 14, and this is the screenshot here. Similarly, in case if I say I want to find out the product of say 2, 3, 4, 5, that is 2 into 3 into 4 into 5, that means I can combine this data in the form of a data vector C 2, 3, 4, 5, and then if I use here the built-in function PROD, then this will give us the multiplication of all the values inside the data vector, right. So, this PROD function, this is used to find out the product of all the values inside a data vector. So, for example, here I try to use this command over the R console, and this value comes out to be 120. 2, 3 is 6, 6, 4 is 24, 24, 5 is 120, right. And this is the screenshot of the same operation. Now, I try to come to the R console so that I can show you these operations, right. So, I will try to show you here the square root, sum and product operation. For example, if I try to find out here square root of here, say here 9, you can see here this comes out to be here 3. And if I try to find out the square root of a data vector, say here 4, 9, 16, 25. So, this will give us the value of square root of 4, square root of 9, square root of 16, square root of 25, this is 2, 3, 4 and 5. Okay, now let me take here some negative value. Let us see what happens. Minus 4, say here 9, 16 and here 25. So, this will give here, what is here NaN? This is something new for us. So, I will try to show you the use of this NA and etc. all these things after a couple of slides in the same lecture. So, this is trying to show you in very simple word that there is some issue, some problem, and it is showing that it is not possible to compute it, right. So, that is what you have to be careful, that for this -4 it is giving us the value NA, something like not available type of thing, and for all other values it is giving you the correct values. Okay. So, now let me give you an idea of the sum function. So, if I try to find out the here sum of say here 5 values 5, 6, 7, 8, 9 combined in the data vector, because this comes out to be here 35. And this sum operator is also valid for negative values also. For example, sum of -3, -4, -5 and say -6. This will again come out to be -18. So, there is no issue. And in case if I try to take here 2 data vectors also, that also can be done, that we already have seen in the earlier lecture. And similarly, if I try to show you here now the product function. So, if I want to make it here product of here C of here 2, 3, 4, 5, right. So, quickest comes out to be 120, 2, 3 is 6, 6, 4 is 24 and 24, 5 is 120. So, it is trying to give us the product of all the values present inside the data vector. So, now if I try to take here one value to be here negative, then let me see whether this operates or not. So, you can see here the answer is coming out to be -120. So, this sum and product function, they are the valid mathematical functions and they are operatable over positive as well as negative values, right. And similarly, if you want to see the use of your absolute function. So, I can show you here absolute of here say this -9 is actually 9. So, you can see here this is happening. And similarly, if I try to take here say a data vector consisting of say here -9, -6 and 7 and here 8. So, you can see here that there are 2 negative values and 2 positive values in this data vector. So, now once you try to operate the absolute function, it will give you the -9 will become 9, -6 will become say 6 and 7 and 8 they already are the positive values. So, their absolute function remain the same. So, you can see here that these operations are not difficult to do in the R software, and they will help us later in solving many complicated functions very easily. And beside this thing, I would also try to show you that just for a quick revision, that whenever we are trying to assign a value to a vector, then it is also possible to assign a new variable to a new vector. For example, in case if I try to say take here data vector of here 2, 3, 4, 5, and suppose I want to obtain the square of all the values, say 2 square, 3 square, 4 square, 5 square, then I can simply denote it here by here x hat 2, and this value can be stored into a new variable here y, right. And once you try to see the value of here y, this will come out to be 4, 9, 16, 25, which is 2 square, 3 square, 4 square and 5 square, and this is here the screenshot. So, that's a pretty simple operation. So, that will help us in assigning the outcome of an operation into a new variable, right. If for example, in statistics you will see at many places we need to find out the sum of squares. So, basically if I want to find out the value of, suppose I have some data vector here consisting of some values x1, x2, say here xn, and suppose I want to find out the sum of squares of these values. That means you first try to square the value and then find out the sum. So, now using this built-in function, you can see here what I can do. So, what I have to do here, that first I need to define here all the values inside a data vector. So, I am trying to define here a data vector here C 2, 3, 4, 5, right. And now this is asking me to find out the square. So, what I can do here, that I need to find out the square. So, I can write down here x hat 2 or I can write down even here x multiplication x, and this is going to give me the value of here say 2 square, 3 square, 4 square and 5 square. And now I need to find out the value of sum of 2 square, 3 square, 4 square, 5 square. So now I can use here the built-in function here sum x hat 2 or say here sum x star x, and this is going to give me the value of 2 square plus 3 square plus 4 square plus 5 square. So you can see here that in case if I want to find out the value of this function here z, which is the sum of squares of different values, then I can write down it here simply like here sum x hat 2, and this value can be stored in a variable say here z, and the sum of 2 square plus 3 square plus 4 square plus 5 square comes out to be here 54, and this is the outcome here. So let me try to show you it over the R console also, so that you get more confidence. So if you try to see here, I try to define here a vector here 2, 3, 4 and 5, and I try to find out here x square, right, and suppose if I try to find out here z is equal to here sum of say x square. So this comes out to be, and if you try to see what is the value of z, this comes out to be 54, right. And similarly, in case if you want to find out the product of 2 square, 3 square, 4 square, 5 square, I can write down here again here is a sum, instead of sum I can write down here product of x square, and this will come out to be 14400. So what is this value? This is the product of 2 square into 3 square into 4 square into 5 square, or simply the product of 2 square, 3 square, 4 square, 5 square, right. So these types of operations are possible, and with this example I will try to illustrate here the computation of a very important or very popular function in statistics. Suppose I want to find out the value of this function here summation I goes from 1 to n x I minus x bar whole square. What is here x bar? X bar here is the arithmetic mean. It is simply here 1 over n summation I goes from 1 to n, say here x I for a data vector here see x1, x2, see here xn. So what I am trying to show you here that if I have got the values I can find out its arithmetic mean, and for that I have some built-in function what is called as here mean, MEAN. So now what I want here first, that I want that each and every value xi should be subtracted from the arithmetic mean, and then this value has to be squared, and then all these values are squared, and then I want to find out the sum of all those values. Now this value can be further simplified as I goes from 1 to n x I square plus x bar square minus twice of x I into x bar, and if you try to open it, this becomes here summation I goes from 1 to n x I square plus n times x bar square minus twice of x bar summation I goes from 1 to n x I, and this becomes here summation I goes from 1 to n x I square plus n x bar square minus twice of x bar, and the summation x I is n times x bar. So this quantity comes out to be the same as I goes from 1 to n summation x I square minus n times x bar square, which I have written here. So now in order to compute this value, what I can do here, that I already have computed this value. This I already had written as say here sum of say x hat 2, and what about this value, next value, what is here n? N is the number of elements in the data vector. So for that there is a built-in command in R which is called here as say length. So, if I try to say here length of here x, so this is going to give me the length of the data vector or the total number of data points in the data vector x. So, instead of here n, I can use here the command here length of here x and multiplied by, for x bar I already have a command, built-in command here, say here mean of here x. So, I can write down here mean of here x and say here square. Well, do not worry, all these commands like as mean, length, etc., we are going to discuss in the further slides, but here I wanted to give you an example to show you that how these built-in functions are going to be useful in computing a very important quantity in statistics. So, now in case if you try to do it on the R console here, so suppose I try to take here the data set 2, 3, 4, 5 and this is the same value. So, I have written here sum of x square which is corresponding to this thing, length of here x which is corresponding to here n, and this here mean of x square here which is corresponding to x bar square. And once you try to store the value of this function into a new variable here z. So, once you try to execute it, first I try to show you here what is the length of here x which is coming out to be here 4 and what is the value of here z, this comes out to be here 5, and this is the screenshot of the same operation, right. Okay. And similarly, if I try to take here another example on the same lines, suppose I try to take here two data vectors, say here x1 and x2 consisting of 4 values 2, 3, 4, 5 and 6, 7, 8, 9, and suppose I want to find out the sum of the product. So, this is something like this 2 into 6 plus 3 into 7 plus 4 into 8 plus 5 into 9. So, I need to find out the value of this thing. So, now I can do it very easily using the this built-in operator. First, I need to find out the multiplication. So, for that I can simply use here the operator x1 star x2. That means, I am trying to multiply the components of two vectors x1 and x2, and whatever is the outcome that I am going to sum. So, this value will come out to be 110. Right. So, before I go further, I will try to show you on the R console that how these things are happening. So, suppose if I try to take it here the same data vector that we have taken it here is say here earlier 2, 3, 4, 5. So, first if you try to see here the length of here x, there are 4 elements. So, it should come out to be here 4, and similarly if you want to find out the here mean of here x, mean of x will come out to be here 3.5, that is 2 plus 3 plus 4 plus 5 divided by 4, which is equal to 3.5. Now, in case if you want to find out the same command here, sum of here x square minus length of x into mean of x square. So, you can see here this function is coming out to be here like this, and the value is coming out to be here 5. And similarly, if I try to take here another data vector here as say 6, 7, 8 and here 9, and if I try to find out the sum of the product of x and y data vector, so this is coming out to be 110. Well, what is this value? This is trying to first multiply the corresponding elements of two data vector x and y, and whatever is the product, it is trying to find out the sum. So, with this illustration you can see here very clearly that this built-in function will help us in many type of operation that we are going to learn in future lectures. All right. Now, after this I would like to address another small topic which is very useful. Suppose someone is asked to collect suppose 5,000 data values, and after the values are collected, they are manually entered on a computer, and suppose there are various possibilities that the number of values present in the data vector are not really all and some data is missing. So in case if a value is missing in any data vector, then how to handle it? This type of situation may occur. For example, someone is asked to collect the data from say 5 houses, and suppose he goes to the third house and the house is locked. So he will try to indicate that this data is not available. So he will use some symbol. So in R, in case if the data is missing, there are some standard symbols which are used, and there are some functions and commands which helps us in modifying the statistical tool and the mathematical tools to handle the missing data. So this is what we are going to learn now in the next couple of minutes. So before I go to discuss the handling of missing data, first let me inform you few small things. There are two letters, true and false, which are written in capital letters, capital T, capital R, capital U, capital E, and all capital letters in F, A, L, S, E. These two are the logical operators, and these operators are used to compare different expressions. We know that in mathematics there are two types of operator, which are mathematical operator and say another are logical operator. Logical operator, for example, say less than. For example, if I say 5 is say more than 3, so this is true or this is false. This is true, but if I say 5 is smaller than 3, then it is false. So here I just want to know the answer in terms of true and false. I am not interested in how much it is larger and how much it is smaller. So these are our logical operators. So this capital letters true and capital letters false, they are the logical operators, and they are the reserved word. Means as soon as you write here, write capital T, capital U, capital R, capital U, capital E, the R will automatically assume it that you are going to use a logical operator. So you cannot use it to define a new variable or any variable from your side. That won't be acceptable. And also in case of here the entire word true or false, you can also use here the first letter capital T or say capital F to denote the words true and false respectively. So T can be replaced for say here true, and say F can be replaced for here false, right. And remember one thing, these true and false have to be written only in the capital letters. In case if you are writing them in small letters, or even if a single letter in these two words is small, this will not remain as a logical operator, and R will not consider it as a logical operator. So this small true and small false, this is not possible, and they are not the same as the true and false in capital letters. As soon as we get any data, then I try to input the data. First option is this, I can input the data in the form of a data vector using the command C. Now I would like to know, is there any value which is missing in the data? So first question is how to know whether any data value is missing inside the data vector. So in order to know this thing, there is a built-in command here, what we call here say is dot NA, and inside the bracket you have to give the data vector in which you want to find is any value missing. So for example, I try to take here data vector here consisting of 4 values 10, 20, 30, 40. Here you can see all the values are present and no values is missing. So I try to execute the command is dot NA and inside the bracket say X, and you will get here an outcome like this, false, 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 false. That means this 10 value is not missing. So saying that 10 is missing or is 10 missing, this is false. Similarly, this false corresponding to this 20. So I am asking with this command, is 20 missing? Answer is false. No, it is not missing, it is present. Now both these 30 and 40, these values are available. So this command is dot NA is giving me a false statement. So this is the screenshot of the same operation. I will try to show you over the R console also. And now let me take here another example. Here I am trying to replace the value 20 from the earlier data vector by here NA. Right, you can see here I am writing here capital N and capital A. This is also a reserved word. I will try to discuss it after a couple of slides, but this is also a reserved word, and this is used in R to indicate that the value is not available. Right. So now in this case, whosoever is entering the data, he has to be told that in case if the data is missing, he or she has to write NA in place of that missing data. So now the data vector comes out to be consisting of here 4 values 10, NA, 30 and 40. So now when I try to operate the command here is.NA, this is giving me the outcome here false, true, false, false. This means here what? This false corresponding to this 10. So I am trying to ask here, is 10 missing? Answer says no, it is available. Hence my command is false. So it is giving me the value here false. Now I come to the second value here NA, and I ask is .NA, and this value, it says yes, this value is missing, and hence the answer is true. My statement is true. And similarly for 30 and 40, these two values are available. So this is trying to say that these values are not missing, they are available. And after this, suppose if there are more than one value, even then there is no problem at all. For example, in the same data vector, if I try to miss two values 20 and 30 here in this new x, so once I try to operate the command here is.NA, then it is giving me here false and false for the values, for those values which are available, and it is giving me the answer true and true for the values which are not available. So by this operation I can always find out whether the values are missing or not. So as long as I am getting here all false, that means all the values are available, and if I am getting even a single true, that means value is missing in the data vector. And now I will try to show you that in case if the value is not available, it is missing in the data vector, then what happens in case if I try to operate any built-in function, right? Okay, but before that, let me come back to here R console, so that I can show you that is it really happening or not. So if I try to take here, for example, here the x data vector here, see here 20, 30, 40 and here 50, right. So this is my here x. So I try to do here s.NA and inside here x, and it is giving me false, 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 false. That means all the data values are available. Now in the same data set, I try to replace the second value by NA. And now you can see here my this x becomes here 20, NA, 40, 50, and if I try to repeat here the same command is.NA, then it is giving me here for the missing value, it is giving me here true, right. And similarly, if I try to make it here more than two values to be missing, so and if I try to operate use the same operator, I get here false for those values which are available and the true for those values which are absent, which are missing. So for the 20 NA, 40 NA, I am getting the outcome false, true, false, true. Okay. So now let me come back to our slide and let me try to show you here that how the things are going to happen when some value is missing. So suppose I try to consider the data set here in which one value is missing 20, 30 NA and 40. Now suppose I want to find out the mean of x. This sample mean is defined as here sum of all the values x1 plus x2 plus xn divided by the total number of observations here x, right. So now in case if you try to find out the mean of 10 plus 20 and NA and 40, this will become here 10 plus 20 plus NA plus 40, number of elements in the data vector which is here 4. And you will see here it is not really mathematically possible to add value NA in any numerical values. So this answer will come out to be here NA, right. Whereas in case if you try to use this command say here na.rm is equal to true, although this command I am going to explain you later on whenever we are going to deal with the statistical function, but here I want to give you an idea that that how you are going to modify the same command when there is a missing value in the data vector. Right. So, in this case, suppose I know that there is one value which is missing in the data set, I have to modify my command mean of x as mean of x. So, I can write down here mean of x here x, and I am trying to write down na.rm. That means na value has to be removed, and this option is true or false. This option is true by writing T. That means all the na value have to be removed, and the arithmetic mean has to be calculated on the basis of available numerical values. So, in case if I try to write down this command here, then this arithmetic mean will be found as 10 plus 20 plus 40 divided by 3, not 4, right, and then I will get here a value here 23.33 and so on. So, this is how we try to work when some values are missing, but let me show you this thing over the R console. So, let me take here the data here x to be here 10, 20, say here na, and here 40. Right. So, you can see here this is my data here, and if I try to write down here mean of x, this is giving you me here na, and if I try to find out here mean of x, na dot rm is equal to true, then you get here the value 23.33. So, here means again just for the sake of illustration, I will try to show you that instead of here using the entire word true, I can also use here capital T, and the answer is coming out to be same. But on the other hand, in case if I try to make it here say small letters, say RU in small letters, this will give me an error. And even if I try to find out this with only na dot rm is equal to small t, that is not capital T, this is going to be an error. So, this is how we try to handle the missing values. But before concluding the lecture, I would try to inform you that in R, in some places you will be getting an outcome like here NULL in capital letters. This is going to be the outcome which is written by some of the function. Remember one thing, NA and null, they are not the same thing. And even this capital NA and small na, they are also not the same thing. Capital N, capital A is a reserved word, and this is case sensitive. The difference between na and null is the following. Na is a placeholder. Placeholder means, yes, inside the class a student has been assigned a seat, but the student is absent today. It does not mean that a student does not exist. So, in this case the student is missing, so that is going to be given by NA, not available at that point. But in case if I am trying to use the word here NULL, this null stands for something which never existed. So, that is the difference between the use of NA and null, which we have to be careful in the while we try to use it. So, here I would like to stop, and I would request you that you please try to attempt your assignment, try to take some exercises from the books, or even you can create your own exercises. Just try to take a data set, do small manipulations and verify them with their manual calculation, that are you getting the same thing which you used to get manually. Try to replace some data set in that data vector by NA and try to see what is really happening. If one value is missing, two values missing, and even if no value is missing, how you are going to obtain or how you are going to interpret the value of this logical operators true and false, right. So, you practice and we will see you in the next lecture. Till then, goodbye.